What we have here is an equation in which we will find the critical points. So, we have here an x cubed plus 3x squared minus 4. First, we're gonna need to get the derivative of the x cubed plus 3x squared minus 4, which is the 3x squared plus 6x. And we're gonna need to equate it into 0. So, to get the x, we're gonna need to plug this equation here into the calculator, in which we equated it into 0. So, we have here 3x squared plus 6x. 3 and 6. So, our x sub 1 is negative 2. And then, our second x is 0. Now, to get the y, we're gonna need to substitute this negative 2 into the original equation, and which will turn out into 0. And same as this one, our second x, and it will result to negative 4. So after that, we're gonna need to make a number line so that we can determine which is the critical point. So here, we will write this from the lowest value of the x to the higher value of the x. So we write here x is equals to negative 2. And what we should do here is that we will follow our domain written here. So we will choose a number which is smaller than negative 2. So we're gonna choose a number that is less than negative 2. So we're gonna choose negative 3. And in here, we're gonna choose a number which is more than negative 2 but less than 0. So what we would have here is negative 1. And then we're gonna choose a number here that is more than 0. So we're gonna choose the number 1. So if we would substitute this negative 3 to this equation, we would get positive 9. So here, we would get the positive 9. So in this number line, we see that this sign right here is a positive. So this just means it is correct. And next is we're gonna substitute the negative 1 to this equation. So notice that we have a negative 3, and in this number line, this here is a negative. So following the same principle, if we would just substitute the 1 in this equation right here, we'd also get a positive number. So by following this domain, we can tell, or we can conclude that if x is less than negative 2, it is increasing. And if negative 2 is less than x and x is less than 0, it is decreasing because it has a negative sign in it. And if x is more than 0, then it is increasing. So, by using this domain, we can find out which is the maximum and the minimum of this equation. So, we can conclude that this negative 2 and 0 here is our maximum, and the 0 and negative 4 is our minimum. So, the next thing that we would do is find the x-intercepts. So, we would replace all the y's into 0. And then, to get the x-intercept, we would plug this equation right here, the original equation, and plug it into our calculator. So, what we have here is the x cubed, so that would be 1, and the next would be 3x squared, so that would be 3, and the next would be minus 4, so negative 4. And this is how we would get our x-intercepts. X sub 1 is 1 and x sub 2 is 2. So, to get the y-intercept, we would substitute all the x's into zeros, and then that would become the negative 4. So, what we're gonna do now is graph the equation. So, we know that we have a negative 2, a 0, and a 0. So, in here, we would graph that negative 2 and 0 and put it into the x-axis, which is the negative 2, and y-axis is 0, so it would just stay there. And what we have next is the 0 and the negative 4. So, the 0 and the negative 4. So, the x-axis is 0 and then y-axis is negative 4, so we would just put the negative 4 there. And then, we have a 1 here in the x. So, here, we will put a 1 and our y is 0. So, we can conclude that we have our maximum here